Hi, this is Joel again. In this video, we're going to look at conditional statements. Conditions are what let your program actually make decisions, not just performing a particular set of steps that you've sort of pre-written down, but basically this decision lets you actually do programming so that your computer can actually do something interesting rather than just effectively like encoding what you want to do already. So note that the examples we're going to go through today are mostly in the textbook. They're actually just copied out of the textbook, but I thought it would be worth going over them and sort of showing them in action because that can be a useful way of sort of understanding how these things come together. All right, let's go. So first thing to make sure to review is that conditional statements are going to be built primarily around expressions that produce booleans. So a boolean is going to be a true or false value that's representing some statement about the world. So for example, is it Monday? That could be a false statement. Or do I need coffee? That is clearly a true statement. We can produce booleans by generally using things like relational operators to say compare numbers or to compare strings. For example, if we want to compare numbers to pi or numbers to each other, we can also then be able to compare strings to each other, and we can use Boolean operations like and, or not in order to be able to take Booleans and combine them together to produce more complex statements about the world. All right, so here's then an example of actual conditional statement. So a condition itself is written using an if statement. So the if is going to be our keyword. And the syntax here is that we're going to use the keyword if, and then we're going to put a Boolean expression. So it's either going to be a Boolean or something that's going to evaluate to a Boolean. So effectively it's going to be something that becomes true or false. This will be followed by a colon and then an indented block. This is the same way that we wrote functions previously. And then anything that goes out that's unindented is effectively going to be outside that condition. Blocks can contain multiple lines, and they can do all kinds of other stuff. So the basic idea with an if statement is that the interpreter, when it gets to this line of code, this if statement, will look at this Boolean expression. If that expression is true, then it goes into this block in order to actually run these two lines of code. Once it does that, it then continues on to the next line. If, on the other hand, when it got to this expression, if that condition was false, then it would never actually go into that block. It would say, I'm not going to do these lines of code, and would just continue on as normal. So in this situation, our port temperature is set to be 130. 130 is going to be greater than 120, so that's going to evaluate to be a true statement, which means that when we execute this cell, then our code ran the block, it printed out ouch, and the port is too hot, and then it moves on to the next line, prints out that it's time for rest, and we go looking for a chair. If we adjust the temperature to say make the port temperature cooler, maybe make it to 110, then when we run our code, our port temperature 110 is not going to be greater than 120. That's a false statement about the world. So because that expression evaluates to false, this if statement won't execute, the block of the if statement won't actually execute, and we won't get to where we need to go. So again, when we execute this line of code, then we check that condition. It wasn't true, so we did not do this work. These lines of code did not execute at all. The interpreter didn't even look at them, and then we just went straight on to after the block in order to be able to say, let's print out that's time for rest and where's a chair. But yeah, so again, it's worth noting that you can have any code that's going to happen outside that if block will always get run no matter what. So the if block itself ends up acting a little bit like sort of a conditional optional set of code that we want to run. If I got this right, then yeah. We can also include an else statement, like the one that I just pasted in. An else clause is going to specify the code that should be run if my condition was not true, or rather if it was false, particularly. So when I look at my porch temperature is greater than 20, if that statement is true, right, if that's a true Boolean, then I'm going to run the stuff in the if statement, right? That's my sort of first case. But otherwise, if this expression ends up being false, then the interpreter will run the else clause instead. So it'll print out these two lines. So as you can see, because my port temperature is currently at 110, which is, as we said, is not greater than 120, so this is a false statement about the world, we're going to do the else block instead. So we execute this code, we see that the port is not too hot, yummy, and we can now go looking for a chair. So because a Boolean expression is either going to be true or false, it's only one of those two values, then that means that if you have an if and an else clause, only one of those two blocks is going to get executed. Either we're going to execute the first because our Boolean was true, or we'll execute the second because the Boolean was false. We're always going to execute one, right? Because it's either going to be true or false, so we're always going to get one or the other. We'll never get neither, and we'll never get both. Because we're just going to do, it's basically, you think very much as an otherwise. It's going to be do this thing or do that other thing instead. I also want to flag again that else clauses are optional, right? The first example we didn't actually have an else. We added in later. You don't always need to have an else clause when you're writing a conditional. Sometimes the code you're interested in is really going to be that if something is true, do some work, but otherwise do nothing, right? If we don't actually want to do anything else when our porridge is too cold, is not too hot, or if we just want to say, great, time for rest, where's a chair, I don't want to put that else and put nothing in there. We would just leave off the else clause entirely. We would just say, great, I don't need to do that. I'm only going to handle this one condition. So else's are useful, but they're not necessarily required. You'll see them a lot. They're not uncommon, but they're not necessary to make everything work. So the other important thing to note about conditional blocks is that they can contain any set of code that we want. So you can assign variables, you can print call functions, you can print out lines of strings, you can do whatever you want inside of there. Any line of any code that you want, including other conditional statements. So we can actually nest conditions and put one if statement inside the block of another if statement in order to be able to make sort of more branching, complex decision trees. So here's an example, again, taken from the course text. So in this case, we're going to set our outside temperature to be 80 degrees. And we can check to see that if our outside temperature is less than 80, we'll wear a jacket. Otherwise, so again, our temperature is 80, which is equal to 60. So in that else case, right, that otherwise situation, we can then make another check. We can then do another condition. We can say, all right, well, but on the other hand, if it happened to be greater than 90, wear sunscreen. Otherwise, we can do another check. So we can actually layer these things down fairly deeply to see how it works. So in this case, our temperature is 80. If we then compare our 80 to 60, 80 outside temperature less than 60 is a false statement, so therefore we're not going to execute this if statement, and instead we'll go into the else. Now that we're in the else, our interpreter will get to this next line of code, and we'll compare our outside temperature to 90. Again, outside temperature is not greater than 90. That's a false statement, so we're going to do that guy's else, which takes us into this block. And then now that we're in this block, we're going to compare our outside temperature to 72. That's again a false statement, so we're not going to do that block. Instead, we're going to do its else block, and that should print it out to wear a t-shirt. So when we execute this code, we should be told that we should wear t-shirts. Awesome, and that worked exactly as expected, which is good. Otherwise, I'd be really, really worried. We can adjust these things in different ways, right? So if I set my temperature to be 50, then now when we compare my 250 to 60, I'm going to say that that's going to be a true statement, so I'm going to do this wear a jacket block, which means that because that was true, I don't need to even consider the else block. It doesn't matter how much other code or there's other decisions in there, I won't consider them because the first thing was true, so there is no otherwise, right? We don't even need to consider the other option. So again, when I execute this with outside temperature 50, I'm told to wear a jacket. Sort of similarly, I'll do a couple more examples, right? So if I say our outside temperature is 95, that's not less than 60, so we're going to go into the else. That is greater than 90, so we're going to print out to wear sunscreen. But again, this way means we won't do this this other else clause because the first value is true, so that when our temperature is 95, we're told to wear sunscreen. Note that because, like I said, conditionals can be we can put conditionals inside of blocks inside of other conditionals, but because blocks can contain any code we want, it also means that we can take conditionals and put them inside of the other blocks we've used, which are function blocks. So for example, we can get rid of our original outside temperature and we can define ourselves a new function, maybe called print outfit, because that's what we're going to do, that maybe takes in the outside temperature as an argument, and then inside that block, inside that function, what we can do is we can do all of our conditional work. So this tends to be a very common structure, way of putting this together, because that way, rather than having to say keep redefining a variable at the top, which we know what it's going to be, we can have a function that'll be able to do different things based on some kind of input. So in this case, I can then be able to say that I want to print my outfit, and I can pass in that 80 degrees, and then it'll do the exact same work. It'll tell me that it needs to wear a t-shirt, and so we're good to go. We can simplify this kind of complex nested structure in many ways by introducing the third option for a clause, which is what's called an elif clause or an else if clause. The elif is sort of just shorthand for taking else and if and cutting off some of the letters at either end. What an elif clause or an else if clause is doing is it's providing a mutually exclusive option. So the way this ends up working, actually I need an outside temperature variable here, I work with. What this is going to then end up doing, sorry, cleaning up my own code, is that when the interpreter executes this code, right, so we'll compare our outside temperature to see that if it's less than 60, right, we're going to run that first condition, that becomes false, and then so because that, we'll go to our else if clause, which means that we're going to say we're in that else, we're now going to check this other option. If that one is true, then we'll stop there. We won't do any extra work. But if that one's false, then we go down to the next option to check that as well. If that's false, then we'll go down to the next option and check that as well. So if we check something that's going to stop in the middle, like we say our outside temperature is going to be 100, then this will see if our if statement, we're going to check our first if to see if the outside temperature is less than 60. It's not, so we're not going to do that block. We're instead going to go to the elif, the first elif. We'll then check our outside temperature to 90. This is true, which means we'll execute this block. And then because we've now found one of those options, there is no else that I need to check anymore. I've already gotten the piece that I care about, right? I've already gotten a result, so I don't need to check sort of any of the other options. It's like we've gone through plan A, that didn't work, so we got to plan B, but that did work, so we never needed to go on to plan C. So that when we execute this code, it tells us to wear sunscreen because it's incredibly hot outside, and then tells us to have a nice day, because again, that's the stuff that happens outside the block. If we were able to get all the way through this, which is what the 80 would do, then that's in case where we'll have the first element option will be false. We check the next one, that was false. We check the third one, that was false. So we get to our final else case, and sort of this is often called literally the final else. This is going to be sort of the if in worst case scenario, right, nothing else was true, do this piece as well. It's not necessarily, there's not a valuation attached to that, but that's kind of the basic idea. And this will tell us the end to wear a t-shirt and then tell us to be able to have a nice day. What else do I want to say about this? Yeah. The other things in the note is that like this elif structure is a sort of more concise way of talking about these things as different, unique, mutually exclusive options. We can actually even convert our previous example where we had sort of this like nested falling down packet of if-else's convert this into the elif kind of structure. By literally just saying, let's take that else part and we're going to delete it and put the if there instead. And then sort of fix our indentation. We'll take this else, we'll put that if there instead. And then if we just sort of re-indent everything, then re-indent. Then we actually get back to having the exact same block of code. So we've sort of taken what looks like this fairly complex set of if this, else this, check all these different things one by one, but because of the particular way we structured that, we were also able to say, well, here's a list of 5 different options because we're only going to pick one of those pieces. The important point here is that these are all mutually exclusive options that are checked in order, right? In this set of options, we're either going to wear a jacket, sunscreen, have perfect weather, or wear a t-shirt. There's never any option for us to do multiple of these things as once. Elifs are very much mutually exclusive. You will do one or you'll do the other. Once you've found one matching condition, you'll execute that block and you will not even bother to check any of the ones further down the line. All right, so here's another example. So we have 2 different cells here, 2 different sets of comparison temperatures about how cold it is outside. So the question is, what's the distinction, what's the difference between these 2 blocks of code? Right, see, this is my way waiting for you. All right, that's right. So the idea here is that in our first block, we're using an elif, which means we're specifying 2 mutually exclusive options, right? We're either going to do one or we're going to do the other. So therefore, if our temperature is 20, which we've executed to be 20, if I run this first block of code, then what will happen is we compare our 20 to 30. That's true, so we're told to wear snow pants, which means we don't even bother to check if the temperature is less than 60. Like this condition is never even evaluated, which means it doesn't matter that it's true because we've specified that this is an otherwise option that's only going to happen if if the first thing didn't happen. Then it means we're only ever going to have to pick one of those 2 options. On the other hand, down here we don't have an elif, we just have 2 if statements, which means this first if is going to check the temperature, it'll evaluate it as true, which means it'll tell you to wear snow pants, and then after the interpreter finishes that, it'll go on to the next line of code. That's not an elif, it's not an else, so it's going to say, great, I'm going to check that condition again as well, which means it'll actually run both pairs of these conditions and do both checks and potentially execute both pieces at once. So in this case, because it's cold out, it'll tell us to both wear snow pants and to wear a jacket. In practice, if you have multiple if statements that aren't actually connected, they're not actually there's not an elif or an else connecting them in any way. It's generally a good sort of idea to put a space between them, make them sort of very much clear that these are 2 separate blocks of work. They're actually doing 2 different things as you're sort of thinking about how these pieces work. All right, let me paste in one more example real fast. All right, what do we do with this case? Give me a second to think. All right, so In this example, we've got, we have an elif clause again, so that means we're only going to check one and then the other. So in this case, if our temperature is 20 degrees, we'll see if our temperature is less than 60, and that's true, so we'll print out wear a jacket. Then, because that was true though, again, we'll never even check this second option. We'll never even get there. We won't even look to see if the temperature is less than 30. We're just going to execute our code, and it tells us to wear a jacket. If you think about this, there is absolutely no value in the world that can possibly make it so that this first value is true, was false, but this one becomes true. So if our temperature is less than 60, then it's also going to be less than, if our temperature is less than 30, then it would have had to have been less than 60. So what that means is that this second option is what's known as an unreachable statement, which I can't spell. So effectively, that's a line of code that will never get executed. There's no way for the Python interpreter to ever actually do that block, because the only way it would even consider this block was if the first thing was false, but if the first thing was false, then this thing will always be false as well, right? There is no temperature that can make this work. What does this mean? So basically, because we're using this otherwise structure, we've sort of adjusted, we've basically created this set of code that can't be used. We've basically written sort of useless code. The thing here is that the interpreter won't actually catch any problems with this language. They won't actually be able to identify that your logic is slightly flawed, that you have this code here that's never going to run. The interpreter is just checking to see if you've got valid things like that is a Boolean or that's not a Boolean. So what this means is you have to be able to think carefully about sort of what are your conditions, what's your if, what's your else, when do I want to do something, when do I not want to do something, and potentially adjust your orderings for how these things might work. So if I really do want to be able to say wear a jacket or then sometimes also wear snow pants, I can use the sort of non-mutually exclusive version that I used in the previous cell, or I could potentially just reorder these things. I'll swap them around. Nope, that's not going to work. But I could potentially, if I swap them around, I get a different kind of effect where I might say that if it's really cold, wear a jacket, but if it's, wait, that didn't work. That was totally the wrong thing to do. I want to swap both of these pieces. There we go. See, doing it live. Where this could say that, all right, if it's really cold, wear snow pants, but otherwise, if it's not really cold, if it's only kind of cold, we'll just wear a jacket. So we can be able to produce that kind of mutually exclusive effects, but we have to be careful about what is the ordering by which we're trying to do these things. And I want to flag again that remember that we don't actually need an else. We also don't even need the else if technically. It's fine to have single if statements on their own. This is totally okay. It's fine to have an else somewhere else. Right, we could say else print that this is a nice day because it's greater than 60. We can sometimes have an else's. We can sometimes have if, elif, else. We can have lots of different options, and we can combine these depending on what kinds of decisions we actually want to make. Okay, so finally, I want to go over a couple of stylistic issues to consider when you're writing conditions. There's lots of different ways to sort of produce conditions that'll work, but there's some ways that are better practice and are going to produce sort of better, more understandable code as you go. So the first thing to note, and this is probably one that you may have encountered in working with through the Boolean exercise, is that we want to be careful about how we're writing out the condition. In general, we want to write conditions so that the variable is going to be on the left side, and the sort of the known value, the thing we're comparing against, is going to be on the right. So rather than trying to check to see if 3 is less than x in order to figure out if x is big or not, we would instead rather write that check to see if x is greater than 3. The first conversion is what's often known as Yoda code or a Yoda condition because it's speaking backwards, right? We're saying big X this is, right? This number is 3 is smaller than our number. What we really want to say is see if X is bigger than 3. So again, these are equivalent statements. They mean exactly the same thing, but we can use a different relational operator and we can use a different sort of ordering of the code in order to be able to make something that becomes more readable and more understandable. This tends to just be better practice, and it tends to sort of make things flow in your mind a little better. All right, other examples. So when you're writing out conditions, if you want to be able to handle multiple different cases, we don't need to use an elif for if there's only two possible options. So for example, in this example, we're checking to see if our temperature is less than 50, if it's cold, and then but if it's less than 50, if it's not less than 50, we don't then need to confirm that it's greater than or equal to 50, right? We don't need to add in that extra condition, because if the first one was false, then we know this one's going to be true. Because of the way that math works, like it has to be one or the other. What we're trying to do here is literally write two mutually exclusive conditions, so I don't need to check something twice. I only need to check sort of the one switch about whether it's cold or not. So what we'd rather do instead would be to just use a plain else statement, right? Check to see if it's cold, and if it's not cold, I don't need to check to see if it's then warm, because if it's not cold, it's going to have to be warm because I've done this sort of this single Boolean operation. If you have multiple degradations of whether, like we did in the previous example, you need to use something like an elif, but don't if you find yourself saying if true, else if false, don't do that kind of work. That's basically ends up being unnecessary and redundant, and it means if you want to adjust things later, you have to do multiple changes, and it makes it much harder to read and understand what your code is doing. Finally, when you're doing comparisons and when you're writing conditional statements, we don't want to try to compare things to true. So is raining is going to be a Boolean. We can tell because it's named is, and so it has that sort of statement about the world. And because is raining is a Boolean, it's going to be either true or false. If it's true, then comparing to see if it's true, like we're basically end up saying if true is true, which is going to be a true statement. It ends up being very redundant. Whereas saying if false is true, that's going to be false, so that's always going to be false. Effectively, you're almost saying that like if the sky is blue, then the sky is blue. It's sort of tautological. So the idea is that comparing values to true ends up being very unnecessary. It ends up meaning you're writing out more code, you are potentially adding some extra confusion, and it makes things harder to read. So rather than trying to say saying that is it raining, if raining is true, is that actually a true statement, we can instead just use that Boolean expression as itself, where we don't need to do any comparison work with it. We can say that if it's raining, is raining is Boolean, we don't need to see if it's a true Boolean because it's either true or false. So if it's raining, we can print out that it's raining. This ends up making it read more like English. We don't have to have this sort of weird like truth, like logical predicate stuff going on in there. We can be able to write something that ends up being much more readable. It tends to be cleaner. It tends to like drive the way you want to use Boolean variables to keep everything come together. This last one, on the other hand, can get a little bit tricky, particularly depending on how you decide to name and structure and design your variables. So there's actually, in general, there's lots of different ways we can write out sort of equivalent conditional statements. So here's an example of a couple different options. And the question, of course, is which is better? So we can say that we can have an if that's going to be if not is raining. We can say if is raining is false. We can say if is raining is not equal to true. Or we could have maybe a different variable where we said actually if is not raining, and we had sort of a single variable that represented that information. So these are all going to check the same thing. They're going to tell us whether it's not raining. And so the question is, which would we like to use? What do you think? All right, well, so here's my stance on a lot of this stuff. In general, the best option I think to use is to use the first one. That's the cleanest option. Is that if we're gonna use a Boolean that represents a positive value, like is raining, and if I want to see if that's not the case, then I'd literally like to use the word not to negate that Boolean. So I say that something if it is not the case that it is raining. It tends to read closest to English. There's the least amount of like potential issues with syntax or forgetting an equal symbol of some kind. So that tends to be sort of, I think, the cleanest kinds of option. Acceptably, it's okay if you want to then use the equivalent, which is we want to actually compare our Boolean to being false. This way you avoid the sort of the if not is raining, which feels a little bit weird. You'll be able to say if is raining is a false statement. That works just as well. I tend to prefer using a not instead of comparing to false. I tend to find it's a little bit less buggy. It tends to read a little bit cleaner, and Python sort of produces those kinds of effects. And actually will match better to other languages that like that a little bit more. Alternatively, we could compare is raining to see if it's not equal to true. This is equivalent to saying is raining equal to false. However, we're now using this weird double negation. We're saying if is raining is not true, I guess we're not really having there's kind of a weird negation issue in there. That ends up making it sort of hard to understand and harder to parse. So I'd recommend not doing that. The last option would be to use actually a Boolean that would be literally, rather than tracking to see is it raining, tracking a variable says if it's not raining, and then we could just do a simple if is not raining. The problem is this often becomes difficult when we're trying to do other kinds of work. So if I wanted to check to see if it was raining, then I'd have to say if is not raining is not, if not is not raining, right? There ends up being this double negation that we end up having to work with. So in general, I recommend that any Boolean variables you create are positive variables, right? They are is raining, needs coffee, is Monday. We don't want to try to use things like is not Monday, it has, does not need coffee. You can adjust this a little bit by, rather than saying that is not Monday, you might say is weekday or is weekend maybe. That will let you then be able to check something that's sort of checked for effectively an exclusive condition while also being able to still use sort of a positive set of language to get that work. Overall, this will produce a more readable, understandable set of code, and it makes it easier for you to keep track of what your variables are and understand your logic and not get lost or potentially have double negatives or have some weird logical errors that are then difficult to debug and will cause further problems in your computer. Okay, I think that's the basics of conditionals. In data programming, we don't really be using a lot of complex decisions. Like we don't have more than maybe one or two nested levels, if that. But we often still want to be able to make computers, so we're often going to have an if, maybe an if else floating around somewhere to be able to make it so that our functions can actually do different things depending on what kinds of inputs are put into them, rather than just having the inputs tweak strings in different kinds of ways. This is what enables computer programs to actually be computer programs and actually do interesting, valuable kinds of work. Yeah, that's what we got.